Look at this line. You've seen it your whole life. 0 in the middle, the numbers running off in both directions. You can count 1, 2, 3. A kid can do it before he can read. You point at things and say how many. These are natural numbers, and the name fits. They are the most natural thing we have. They feel like a solid ground, so we stand here and count. For a while that's enough. You can add, put piles together, you can multiply, the same thing but faster. The ground holds, right? And then you try to take away. Take 3 from 5, 2. Fine. Now take 5 from 3. Where did you just go? You ran out of numbers. Counting starts at 1. It has no answer for less than nothing. For a long time, that wasn't even a question you were allowed to ask. There was just nothing there. We built the numbers behind 0, the negatives. Now you can always subtract. The line runs both ways. And notice what happened. We did not find those numbers. We needed them, so we made them. The reaching came first. The number came second. Remember that. It is the whole story. Because it happens again. Now you try to share one thing to people. You cut it in half. But half is not a whole number, and there is no whole number that is a half. You've run off the edge again. Same fall, but different edge. And again, we build. We fill the space between the whole numbers with all the fractions, every ratio. This many parts out of that many. We call them the rationals. And now something strange happens. Watch. Take any two fractions, as close as you want. A half and a third. Is there a 1 in between? Sure, the average right in the middle. And between that 1 and a half, another, and another. No matter how close two of them are, you can always fit one more in between, forever. So there are no gaps. At least that's how it looks. The line feels full now, packed, tight, all the way down. And honestly, you would think we're done, that every point finally has a number sitting on it. Let me draw one more thing, a square. The simplest one. One step across the bottom, one step up the side. Now, look at the diagonal. It has a length. You can see it. You could lay a string along it, multiply it by itself, and you get exactly 2. So it's a number whose square is 2, which means it is a number. It sits on our line somewhere, a bit past 1. We just have to find which fraction it is. Here is the problem. It is not a fraction. Not a half, not a third, not 7 over 5. Nothing. Search the whole packed line forever, and there is no fraction whose square is exactly 2. I will not do the full proof here, but here is the shape of it. Assume the fraction exists, fully reduced, nothing left to cancel. Follow the logic and you find the top and the bottom both have to be even, which means you could have cancelled them, so it was never reduced. It contradicts itself, it just cannot be written as a fraction. So look at what we've got. We built a line we thought was solid, we packed it infinitely tight, then we drew a square, and that length is not on our line. There is a hole, right there, in the middle of something you can see. The line you have trusted your whole life has a gap, exactly where the corner of a square lands. So look at the pattern. You reach past counting, we build the negatives. You reach past the whole numbers, we build the fractions. Every time the number was not there. Every time we build it. The reaching came first, the number came second. This is just the next edge. The diagonal is reaching past the fractions, the same way subtraction once reached the past counting. And if the pattern holds, and it does, there is a number out there to build, we just haven't built it yet. Except this time is different, and I'll be honest with you about it. Every number we built before, we could basically point to. Just behind 0, just between the whole numbers. But this one lives in a hole. There is nothing there to point at. It is defined entirely by what it is not. So how do you build a number out of a hole? How do you make something real out of the shape of what is missing? And that's where we go next. There is an idea, a strange, a beautiful one, that reaches into the gap and builds the missing number out of the emptiness around it. It is the tool made for exactly this kind of dark. For now, just hold onto the diagonal. It is real. You measured it, and it has no number yet. Keep that with you. We're gonna light this next time. Just a quick note before you go. A team building a tool called Fenzo reached out to me. The idea is simple. You tell it what you're stuck on, and it builds a small interactive course around your exact gaps. This is pretty much close to what I tried to do in these videos. If math is something that scares you, it might be worth taking a look. There is a free version. The link is in the description section. Try it and judge for yourself. Alright, see you next time.